Looks like we have some new people. So welcome. So maybe anyone who wasn't on the last call, if you could just stick your name in the chat, and we'll just kind of intro everybody so everyone knows who you are. That would be great. Brian, I think you were here before. Yeah,
only new people. Okay.
Yeah, just new people. Yeah, we just want to introduce some new people. I think we got consensus segment. Okay. Yeah. Well, let's kick off. Gavin, do you want to introduce yourself?
Sure. Yeah.
I guess most people know you.
Hey, I'm Gavin from Tendermint Networks. I'm here. I don't have any technical involvement. I'm just really curious and here to learn.
Okay, cool. Colin?
Hey everyone, Colin Myers here. Part of Consensus in a few different capacities, most recently a project called Activate, which is tied to staking in an indirect manner, and we will also be a validator for the networks that we support. So we're doing some things around ETH2 as well, and some research initiatives around economics and other things. So this is a topic that has certainly come up. Excited to continue to have a conversation about it and see where we go.
Great. Thanks, Colin. Mara, do you want to introduce yourself?
Hey, Mara. Nice to meet you. So Colin kind of just gave a quick intro at what we're working on Activate. We're both sort of tackling the staking topic from a few different angles, and especially on liquidity on staking positions. That's kind of something that I've been diving into a bit more and chatting to some peeps, some of which are on the call as well. So I'm excited to chat with you guys.
Cool, great. And anyone else? Is there anyone else that didn't introduce themselves last week or 2 weeks ago? Okay. So let's kick off. So let me just fire the agenda in here. Just give me 1 second. So the agenda is up on GitHub. I just put the link in the chat. And by the way, anyone who wants to raise an issue on GitHub, feel free to do so. We want to have discussion around this. So if you've got anything to talk about, just raise an issue there, and hopefully we get a discussion going. Yeah, so just back to what we want to cover today. As we would have mentioned on the last call, the goal of this whole effort is to deliver a research document around the whole liquid staking area. So what we wanted to do is, myself, Felix, and Brian have been trying to think what the table of contents for that document would look like. So Felix is going to run through that, just to explain, what we think the possible deliverable for this will be. So we just want to get your feedback, and then, so basically we're going to start with the table of contents, and then as the weeks go by, we hopefully flesh that out with more details in each section. And then after that, Sunny is going to present the delegation voucher solution. He mentioned it on the call 2 weeks ago, so we thought it would be a good idea to start there. It's possibly one of the easier models to explain. There's some of the liquid staking solutions get pretty in depth, so hopefully it's a good place to start. And then over the next few weeks, we hope to have all the other projects that are building liquid staking solutions have a chance to kind of present there. So we'll just have a short presentation from Sunny, and then hopefully leave plenty of time for discussion and questions. And then I think to wrap up, we just want to get some agreement on what the agenda for the next call should be. So the next call will be the 5th of February. So like I said, we probably present 1 or 2 of the liquid staking implementations, but yeah, we just want to see if there's any other topics that people would like to bring up. Okay, so I will hand it over to Felix, and Felix can walk you through our draft table of contents. Thanks, Felix.
Yeah. Hey guys, glad to see so many join today too. As Brandon said, I'm just gonna share my screen now and kind of show you the table of contents that we have so far and just go over every section and quickly explain what we're thinking to include in that chapter. And then maybe afterwards we can have a discussion of what is missing or what maybe should be different. We will also put this up on GitHub, and then we can also comment offline if you wish to do so. Share my screen in a second. Okay, so basically this is right now just a Word document. And so we're going to start with the abstract as normally usual. So the abstract kind of just explains the topic and the reason for why we're doing this research and doing this report. And then also the results, the outcome of it shortly in like 1-2 paragraphs. Then we're going to turn into some kind of introduction to proof of stake for those that are going to read this report that don't understand it, or like just introduce the main terminologies and what it's about. So this is mainly like topics like, yeah, Sybil resistance, proof of stake as kind of this control mechanism, the use of collateral to do this, also staking, the role of validators, the earnings of validators, so staking rewards, and kind of go into how big this market is, going a bit into the networks that launch proof of stake and the market size. And then slowly going to the problem that this liquid staking is supposed to solve. We're going to discuss kind of these ideas about lockup periods and slashing, so kind of protocol things that introduce specific limitations to stakers that they ideally normally want to like somehow circumvent and build kind of products around it, which is the liquid staking idea. And we're just introducing these here so people understand why is there even like a different model maybe needed, or what is out there. Then and after that we go to like liquid staking itself. So here we define what we mean by that and the motivation. So essentially what I just said, basically the ability to trade staked position or staked tokens, or maybe even tokenize the staked positions and use them in some other decentralized finance or centralized finance or whatever other context. Then we want to introduce like a taxonomy of liquid staking. And here basically we split it into kind of 4 different types. So one of them is custodial, one of them is non-custodial, the third one is native, and the fourth one is synthetic. So the idea is custodial, meaning solutions that require some centralized entity, like a custodial entity, to manage private keys and then issue or somehow enable liquid staking or issue a tokenized staking voucher or whatever. So that would be kind of exchanges or custodians allowing their customers to trade, or any other type of this model. Might read the comments. Let's see right now if there's something. Okay. I think, we'll get to that later. But yeah, then non-custodial being more solutions that are a decentralized protocol. What that means is basically it's either a separate blockchain or a smart contract on a blockchain, or some type of decentralized protocol that also issues some kind of liquid staking token or enables people to trade these stake positions. And native, we kind of separated it out, even though it's kind of also not non-custodial. We're talking here about building it right into the protocol as like the core staking model, that there doesn't, or that these limitations maybe don't exist, or that these staking derivatives kind of straight up exist from protocol from the beginning. And then synthetic, we added that this is kind of a idea that you can also represent staking rewards as kind of a synthetic token maybe. And if this is like another competitor to other solutions, so maybe as an idea, there could be like an interest rate swap between 2 parties or something, that one guy pays the other the staking rewards as a variable interest rate, while the other pays some fixed interest. So I think this might be like another approach to liquid staking that we also want to definitely also consider. Then in the second part, this is kind of mostly the introduction. We then plan to kind of talk about why or what liquid staking enables. So these are more kind of the advantages or the benefits of it. So that's the first thing being like this being a building block for decentralized finance. So this kind of this money Lego argument. You can use the staking token in other protocols as collateral. You can build stuff on top of it and things like that. And also tokenized staking positions potentially improve the user experience and also enable different kind of financial products that maybe weren't possible before. So maybe like slashing insurance or other things like that. So we quickly want to kind of cover what might be possible there and why that is potentially good or bad. Improving liquidity of staked assets, I put it here. This is basically just this argument, okay, you can now trade these assets. Otherwise you would be exposed to this liquidity risk if you want to unbond your tokens or kind of sell them at a short notice. The price discovery argument is basically, okay, this is the idea that if all the tokens are staked, right, there's no trading happening on these, then if only a small fraction, let's say on Cosmos, maybe 80% are staking, only 20% are in the free market being traded. So there's less trading happening. So a small trades can maybe impact the volatility more than needed. So actually, staked assets might improve this price discovery by moving it to this derivatives layer, the trading, and kind of enabling investors to trade on future events or also like the future. Yes, then we turn to more the negative side or the potential kind of concerns with liquid staking and this kind of network security. We split it now into kind of these 4 points: systemic risk of over financialization, let's say, stake centralization, maybe like the issuer of this liquid staking version has some increased power and can centralize stake. So for example, if only an exchange offers this, all the stake might move there. That's one concern. Then we consider impact on the validator incentive. So does the existence of these staked positions, tokenized staking positions, impact validator incentives in some way? So this is the kind of the concern, oh, the validator will short his own token and then double sign and profit from it, things like that, and kind of cover those ideas. And then also the impact on governance. So maybe having these liquid staking positions might enable people to more easily do token buying or vote buying in governance and on-chain governance questions. Then I forgot to mention before here in the part of the examples, we will then also introduce kind of the solutions that currently exist and some go kind of quickly explain how they work and who's building them. So this is basically like Stake Capital DAO, Stuffy, Everett, this delegation voucher idea, or maybe just KuCoin, Pool X, I think. So we kind of would explain this with examples to help people understand what is out there. And then finally, we would ideally come up with this framework to evaluate these different approaches. We came up with this idea, so this is also what we discussed a bit in the last call. So we wanted to discuss the desired outcomes of what do we want to achieve as a community with these liquid staking positions. What are some good things that we need? I think we had fungibility, we had the decentralization friendliness, we had non-custodialness, that might be a point to discuss. We had non-subtractive to security, modularity and flexibility, and non-subtractiveness to governance, for example. So we would then basically try to evaluate different approaches, looking at these criteria that we come up with, and maybe kind of try to make some judgments about what is maybe better, what is worse, and in the final part conclude draw some conclusions from that and maybe make some recommendations for the Cosmos Hub, as this is an ICF funded research, and then have some future work items and references. Okay, so far that's basically what we have. As I might have mentioned, this is by no means final or anything. So this is just like a structure that we in the past few weeks decided upon, and obviously we can add stuff to that and have different topics in there. I saw in the comments someone mentioning this legal dimension. That could be definitely something we also discuss. I'm not sure. So yeah, maybe let's open it up a bit for questions, if there are any.
Yeah, just in case anyone didn't see in the chat, I was wondering if regulatory environment would be out of scope. It's probably a big topic, and it may be kind of outside of. This is more of a technical and like it's within the system. But anyway, just something to consider.
Yeah, I mean, I think there's some challenges when it comes to covering regulatory environments. So first of all, I think it will depend a lot on the particular implementation, right? So I think different implementation might have very different regulatory consequences. Of course, then we're going to have, we're going to have a lot of differences in different jurisdictions, right? Maybe something is a security in one, but not in others. That being said, we can have a discussion after this call internally whether we can cover it to some extent. Maybe it's possible to do something.
Yeah,
it's definitely a super important topic, so I agree with that.
Yeah, instead of covering it as a massive topic with like all different possible jurisdictions, it may just be worth kind of getting a feel for what the regulatory environment may be like, getting some like input from people who may be experts, and then using that to kind of guide, or like maybe it'll influence the implementation.
Yeah. We'll look into it if we can do that. Yeah. So I guess probably. Yeah, let us come back. Let us respond to that maybe in the next call, but maybe we can have a brief discussion then to what extent.
Anyone else with some comments or questions or ideas?
Just because I wasn't part of the first one, first question on the overall, I guess, putting together the document. Who's kind of holding the pen on it? Is there a feedback loop, an editing process, or just kind of structurally? I just want to understand better.
Yeah, so basically, this is mostly led by us, of course, one. I am kind of penning or kind of coordinating the writing process, I would say. Brenton is more like the overall project coordinator. Where we have these calls, and then we will just post this on GitHub. Probably we'll also have like a shared document soon, and then maybe we can kind of have people. I don't know. It depends on how people want to contribute. This is not something that's really rigid right now. So if you want to like maybe write about a specific thing, just let me know, and we can kind of include that. Or if you have some research already done that you might want to have included, that's also totally possible. But generally, we will probably have some draft version, and then we just let everyone kind of read it, comment, and we'll evolve it over time. And yeah.
Thanks.
Just very quickly, like the last two comments sort of like made me think around, because securities, it's either, you said, okay, let's not call it staking derivatives, otherwise it's a security. But if a derivative is a security, then it's a security also the main asset, right? That you are
Yeah.
building a financial instrument on top. So I said, how can be the derivative a security of something that is not a security? So it's like either is a security in terms of like, it's a financial instrument, or a security that means that you are owning something that gives you the right to something else, which is like equity or whatever, right? That was all the dichotomy. So it's interesting how we can interpret like staking derivatives is an instrument, is a security, but it's always a product that comes from another product. So we need to see the underlying.
Yeah, I mean, I can maybe answer it briefly. So again, it's like a complicated topic. We did have some discussion with lawyers about this, and I think it's possible to have something that's not a security and then have some sort of contract of it being a security, right? So you have, let's say, commodities, and then you have some sort of commodities, options, or futures that may be regulated as securities, even though the underlying thing is not. So
Yeah,
of course,
totally.
if the staking token itself is a security, then that's like extra. Then it's almost certainly going to be messy. But even if the underlying thing is not security, it doesn't necessarily mean that creating some sort of thing on top, it doesn't also risk falling into these buckets.
Yeah, I would second that. What is the underlying primary asset if we're talking about a direct like crypto derivative versus like a staking derivative on a non-security classified primary asset? I guess there's like a delineation between those two as well.
I didn't catch that. Brian, did you catch that?
No, I couldn't really understand it. Just
Yeah,
there's
can you
like
repeat
quite a
that,
bit of
Mara?
background
Sorry.
noise.
Hi, yeah, sorry. Can you guys hear me?
Sure. Yeah, it's just a bit
Yeah.
noisy. Yeah, if you can kind of talk loudly.
Yeah, consensus Bogart is definitely noisy. Yeah, I was just saying that I guess the delineation is also if it's like a crypto derivative on an underlying non-security classified primary asset versus like a staking derivative on a non-classified security as the primary asset as well. So there's like the delineation on those two from that perspective.
Yeah, I don't think we know. I think that's why we left it out of the scope. And when we agreed the scope of this with the Interchain Foundation who are backing this, we kind of left the regulatory stuff out. Mainly because the terminology you're using, I guess, is very US centric, right? And this is a kind of global project, so it's not quite clear like exactly where it's going to lie in each different jurisdiction. I think it's probably clearer in the US. Not necessarily in a good way, but in the rest of the world we don't know. There's various different definitions, and I think that's why one of the projects that we're going to present today, like Sunny's going to go through, is around this delegation vouchers model. Potentially, if we make the issuance of this in protocol, so it's part of the actual delegation action, then maybe there is no derivative, right? Maybe the liquid asset that's generated is just generated at source. It's not a derivative of some other asset. So, potentially that's the solution, but we don't know. So I think there's probably another working group for the legal side of this that that maybe comes later when we figure out the technical option.
I personally think technical options should supersede legal, and then figure out how it actually works first. I support in protocol anything that takes place inside of the network or any tokens that are generated inside of that network. If they don't have a use, then if they're associated with the token, it does have a use, and then the other token created doesn't have a use and can't really be used aside from holding or receiving passive income. It's difficult from the research that we've done. It helps if it's all in network instead of like an outside service provider creating a protocol or creating some type of manual software or SaaS to do this. That's when it kind of gets a bit more difficult. If it can exist inside of the protocol, it certainly helps the case. and it's probably more technically, I guess, viable in my opinion. So I'm excited to hear the end of protocol thoughts on it, because I think that's the best way to get it done.
Yeah. Okay. Any other comments on the table of contents? Anything that's missing? Anything we don't like? Like what about the taxonomy? Are we happy with the taxonomy that Felix is suggesting?
I think it covers everything that we know today, and it may include new items, but I would suggest that if like an out of scope legal discussion or tax category discussion was included in this, it should maybe stay separate. But as of right now, I think it's pretty tight, personally.
Okay, great. Yeah, so I think as Felix said, like we'll share the document as we go. It'll be available as a Google Doc, so you can comment, and so certainly not the last opportunity to comment on it. And I think as Felix always also said, you know, we want this to be a community effort, so feel free to contribute different sections or different ideas. Like Felix will act as the kind of editor, but you know, we want to make sure that everybody has a chance to contribute. So feel free to make some contributions. If there's no more questions, I'll just throw it out one more time. Any questions before we move on to Sunny's presentation? I guess there's a question there. Do we have more resources on staking insurance? Felix, do you want to answer that? Like, that's kind of covered in there, right?
Yeah. So far, I mean, there's not too much public, I would say. I guess Marwan is on this call; he can also comment. But we also, I think Nexus Mutual is kind of looking at it, but I don't think they have anything really public. And I mean, there's been a lot of discussions in different Telegram or other ad hoc things or Cosmos Forum. So maybe we can include those, but yeah, have to search this to it actually. Marwan, any comments?
Well, more resources. How? I mean, what do you want?
So I just wanted to explore, like, you know, just the problem, which is like double signing and shorting problem. So let's say if we have insurance on that same validator, then it brings more trust from the delegator perspective.
Yeah, well,
So,
this is exactly what we are working on.
That's why I just wanted to read upon some resources, like how it works and all.
Well, we are probably going to start sharing stuff this week. It's going to be public, probably in Chorus One group.
Perfect.
As well. So there are some resources that are going to be published.
Mm-hmm. Sure. Thanks.
Welcome.
Great. Yeah, and then I guess in answer to the question, then once they're public, we'll definitely include it in the scope. I mean, it is in the official scope that we've agreed with the Interchain Foundation to cover insurance. So that's great. We look forward to seeing that, Marwan. Okay, if there's no more questions, then I'll hand it over to Sunny. Sunny, do you want to take over?
Yeah, sure. Hey, all right, let me share my screen. Okay. All right, can you guys see the screen and hear me?
Yep.
Cool. All right, so I'll go ahead and walk through sort of my design for the fungible staking derivatives. Or I don't know if we don't use the word derivatives after that conversation, but I don't know. I'm gonna keep using it for now. But yeah, so this is a post I have. It's in the like Cosmos forum. There, it's called like a design for fungible staking derivatives, and it's very much, you know, it's a design for how to do the native variant of staking derivatives. And it sort of is meant specifically for the Cosmos SDK because it's designed in such a way that it handles a lot of the oddities that show up in the Cosmos SDK, which I'll walk through now and hopefully make sense. So the forum post is a bit difficult to understand, and so that's why I hope this walkthrough can make it a bit, allow people to understand it a much easier. Okay, so the first thing we're going to start off with is at the Hackathon Berlin last summer, Chorus and Sikka came up with this delegation vouchers system. And I'll quickly walk through that just for the basics, and then so that way, and then I'll show you why it doesn't quite work for what we want to do in the Cosmos Hub, and then how we go about fixing it. If anyone has any questions, please like interrupt in the middle. Yeah. Okay. So this is the delegation voucher system. So let's say a user wants to go ahead and delegate some atoms to the validator. What they would do is they could go ahead and delegate 100 atoms, and what you do is you get back some certain number of shares. Most of this accounting is actually what's already happening in the staking module of the Cosmos Hub, but all we're going to do, the main change we're doing now here is instead of shares just being a number that's accounted for in the right now, each delegator's shares is just a number accounted for in the state of the staking module. Instead, what we would do is it would actually be a token that's returned to the user. So now they have 100 shares of that validator. And we keep track of the conversion ratio between atoms to shares. And so that way, if another user comes in and deposits 100 atoms, they also get shares back at the same atom to share ratio. So they'll get back 100 shares. So now there's a total of 200 atoms in the pool and 200 outstanding shares. Now let's say there's a 50 atom reward that was added. So, you know, the validator staking, and now there's 250 atoms in the pool and only 200 outstanding shares. What this means is that the conversion ratio now has increased to 1.25 atoms per share, just the number of atoms over the share, over the outstanding shares. So what this does is when one of the users says, okay, you know what, I want to unbond half my amount, right? So I have 100 shares, I'm going to unbond 50 of them. So it will go ahead and return to the user atoms at that conversion ratio. So now there's only 187.5 atoms left in the pool, but because it gave 62.5 to the user, but the number of shares also went down because the user unbonded or burned 50 of those shares, right? And so you'll notice that when people bond or unbond, it doesn't ever change the conversion ratio. The conversion ratio only changes when the validator gets rewards, or if it gets slashed, right? So if the validator gets 100, like let's say you got a slash of 100 atoms, right? It suddenly dropped the current number of atoms in the pool from 187.5 to 87.5, but the number of outstanding shares is still the same. So all that we did now was change the conversion ratio. And so, you know, let's say the user tries to unbond 50 shares, they'll get back a much lower amount of atoms than they did earlier because conversion ratio has decreased due to slashing. So whenever there's rewards, the conversion ratio is always going to be increasing. And when there's a slash, the conversion ratio will decrease. But now here's where the problem comes in. What happens, you know, in the Cosmos SDK, we've designed it such that fees are meant to be able to be paid in any asset that you desire, right? Or at least any whitelisted fee token. And so what happens if the reward is in some other asset other than atoms, right? Let's say it's in 100 photons, you know, not that we know what photons are yet, but, you know, let's say it's in 100 photons. And now, look, what does this mean? Like the current pool has atoms and photons and the shares, but the conversion ratio, like, does that mean that the conversion ratio is 0.58 atoms and 1 photon per share? And does that mean when you want to bond, you have to put in 100 atoms and some photons? Like it doesn't really quite, you know, it doesn't really make sense. Once you start putting other stuff into the pool, along with the atoms, then you don't really know what the conversion ratio means anymore. And this is important because, you know, let's say someone Yeah, okay. So, actually, okay. So, to solve this, that's why in the Cosmos SDK, we developed this thing called the F1 fee distribution. And so, if anyone is part of the Game of Stakes last year, you might know this thing because, it was causing a lot of bugs and stuff. But essentially, the key of what it's doing, so this is sort of what the delegation struct looks like. But what the F1 fee distribution does essentially is it keeps track of what happened when a specific validator. So rewards are not automatically rebonded. So one thing you'll notice is in the voucher system, this is essentially auto rebonding rewards. But in F1, it doesn't auto rebond the rewards, and it keeps track of, let's say the reward pool for a certain validator has 500 photons in it at time 5. And then you bond into that validator at time 6. The F1 fee distribution system makes sure that you are not entitled to those 500 photons. You don't get a share of those photons. You only get a share of the tokens that enter the reward pool after you bonded. And this is sort of, and conversely, it also makes sure that, if there was a slash that happened before you joined, then you don't get punished for something that, your atoms are not going to get slashed if you join afterwards, right? So that's what the F1 fee distribution does. And we kind of need this to, if we want to have multi-fee tokens, if we want rewards to be able to be paid in multiple tokens, which is, especially when we start to get to like shared security stuff, I imagine that's, that's going to be very necessary, I think, for the UX of the shared security model to work. And so this is sort of how I kind of structure my things. I have my pseudocode. So I have these constants. These are the constant fields of a struct. You have the variable fields, and then you have the capabilities or functions. Like what can you do if you are the owner of that struct? What can you do with it? So the thing that's important here is the reason that these are you can read the F1 fee distribution spec here. So what we could say is, hey, what if we just turn this thing into an asset? So this is the delegation struct that is already in the state of the staking module. Why don't we just turn this into an asset so that way, instead of it be like, instead of the from delegator being in the state saying like, saying, okay, who owns this? It's, this person. What if we just make it into an NFT, right? Where whoever is holding the NFT is the delegator, right? So if I give it to someone else, then they would become the delegator. So why is this non-fungible though? Why is this non-fungible though? It's non-fungible because of that last withdrawal time that the F1 fee distribution needs. So because, let's say I delegated to Sikka at, time 10. Last time I withdrew was time 10, but, let's say someone else, Felix, delegated to Sikka and he hasn't withdrawn his reward since like time 0, right? The fee distribution system has to keep track of when was the last time each person withdrew their rewards, so that way it can, when Felix withdraws, he'll get more rewards at that time because it has to also give him the pro rata rewards for time 0 to 10, while if I withdraw, it'll only give me the pro rata rewards from my last withdrawal time to the current time. And so because of that last withdrawal time is different for every delegator, these delegation assets are non-fungible. And what is the issue with them being non-fungible, right? So, you can trade them OTC, which is fine, right? Like, I could go up to, Brendan, I can be like, hey, look, here's my delegation NFT. You can see how many atoms on there. You can see how many, when's the last time I withdrew, and we can come up with our deal ourselves. But you can't put it really into like a Uniswap style thing because they're non-fungible. Or you know, it'd be even very difficult to put them into like an order book like exchange as well. It really only works on like a OTC system. And it's also much more difficult to reason about and thus much more complex to use in DeFi. So imagine like, you know, Kava CDPs. We wanted to use these as collateral in the CDPs. You know, price oracles would have to give the value of each of these delegation NFTs separately because they're going to have separate values because their last withdrawal time is different. So, okay, so here's solution number one. What we're gonna do is we're actually gonna keep a delegation struct in state, but we're gonna create a separate asset called a delegation claim, which is still an NFT for the moment, but we'll explain how to get that finish turning it fungible. But for now, it's still an NFT, but what it does is it refers to a specific delegation in state. So and what you can see is the functionality it has is this ability to change the withdrawal address. So let me walk through how that works. So let's say Alice wants to delegate to this validator A, right? So she'll go ahead and say, okay, I'll delegate 100 atoms. And what will happen is in state, it'll create a new delegation object, which, you know, let's say the ID is A1. It's the first delegation to validator A. It's to validator A. The withdrawal address is Alice. It's 100 shares. And the last withdrawal time was time 50. Now, let's say it's time 100 now, and the validator has accumulated some rewards. So Alice can go ahead and say, okay, withdraw. It will send her back some rewards, and it will update the last withdrawal time to 100. Now, let's say she wants to unbond 50 shares. It could do that as well. You know, it will unbond 50 atoms, and it will reduce the number of shares. That still all works the same. Now, what happens when she wants to sell this asset? She wants to sell ownership of this asset. What she can do is she can go to Bob and basically sell her the NFT that is a claim on delegation A1. Now, Bob is now the owner of this, and he can go ahead and unbond if he wants, and he'll get out 10 atoms. Great. So now the shares went down by 10, and he got back 10 atoms. But let's see what happens when he tries to withdraw. He says, okay, I'm going to withdraw rewards. The last withdrawal time went up, but you'll notice that the withdrawal address is still Alice. So the rewards actually get sent to Alice. So what actually needs to happen is when Bob receives the asset, he needs to first say change withdrawal address. And what this does is it first takes all the rewards that have been accumulated thus far, gives them to the last withdrawal address, which is currently still Alice. Then it changes the withdrawal address to Bob, and it resets the last withdrawal time. So what this means, and gives him, and then, you know, he can withdraw. And so what does this mean? Like, why are we, this makes it so it doesn't matter which, and let's say you have the option to buy the delegation claim from Alice or Charlie, right? And they both have the same number of bonded atoms. Let's say it's 100 shares, right? But Alice has not withdrawn in months, while Charlie has withdrawn, you know, just yesterday, right? In the previous system, you would want to buy Alice's, right? Because, you know, there's more rewards there. But what we've done here is it doesn't matter whether you buy Alice or Charlie's claim, because when you buy either one of them, the first thing you do is you change the withdrawal address by sending that function. And then it takes all the rewards that have not been claimed yet and gives them to Alice or to Charlie. And then you only start to start accumulating the rewards from the point after you call change withdrawal address. So what this does is it makes both of these assets fungible, because they both have the same capability, which is to start accumulating rewards. It doesn't matter what rewards are already been accumulated to the past owners, because those will get given to the past owners. And so that kind of makes them both sort of fungible. Now, this change withdrawal address, I mean, you know, one of the cons of this is, let's say you have, so the struct is on the Cosmos Hub, right? Let's say we're staking on the Cosmos Hub, but we're on a separate chain, right? And we've moved that NFT, Alice has moved that NFT onto a separate chain. She can, you know, sell Bob the delegation claim. But the problem is Bob is not going to start earning the rewards because the withdrawal address is still Alice on the Cosmos Hub. So he actually does need to IBC it over to himself on the Cosmos Hub, change the withdrawal address, so now it gets set to Bob, and then he can, you know, send it back to himself over there. So this is one of the more, you know, it is kind of a little bit annoying that you have to do this, but this is sort of how it has to be done so that the withdrawal address in state can has to be, you know, you have to be able to update it. The question is, do you always need to change the withdrawal address? I would say not always. So sometimes, let's say you're trading really quickly, right? And let's say you're on this other chain and you're just trading really quickly on like Uniswap, you're doing some arbitraging or something. Maybe it's not even worth changing withdrawal address because like the amount of time, the amount of rewards you get in the time that you're like holding the asset, maybe it's actually barely any rewards, like not maybe because you're trading these on like a minute to minute basis. So maybe the rewards aren't actually that worth that much. Really, it's like the potential for someone else to buy that asset and start claiming the rewards themselves is what gives it value. And so, you know, maybe it might not even be worth like the IBC fee to do that. Weirdly, so for the buyer, like I said, it doesn't matter to the buyer. It's the ability to change withdrawal address that makes it valuable. For the seller, it is sort of in this weird kind of like, it's a little bit odd because it is in the seller's incentive to sell to a lazy buyer who will be slow to make the change. So let's say I'm Alice. I can sell to Bob or I can sell to Charlie. And let's say I know Charlie is like really lazy and he's not gonna actually go and like update the withdrawal address for like a few days at least. I would rather, and Bob, I know, he's on top of his thing. He'll go do it immediately. Weirdly enough, I'd actually rather sell to Charlie because for those few days he takes to update his withdrawal address, I'm actually earning extra rewards even after selling the asset. But, really, the fungibility really comes from the buyer's perspective because usually it's if you think about it in a Uniswap market, as long as to the buyer it's the same, that's what really, sort of matters. So, and if you are long-term holding an asset, then yes, it is worth going to change the withdrawal address. Okay, so great. We're almost done. The only problem is here, it's still a non-fungible asset, because the withdrawal address isn't what matters anymore. It's only now non-fungible just because the shares are different, right? Let's say, Alice has delegated with, 100 atoms and Charlie has delegated with 50 atoms. Obviously, their delegations are not not worth the same amount, and thus their delegation claim can't be worth the same amount. So to make this fungible, we want to turn these into tokens. And so what we can do is the final iteration of this model is we say, okay, we're still doing the delegations as a struct in chain. We're going to stop calling it the withdrawal address. We're just going to call it the owner now. And we're going to create this delegation share token. So you can think of this like a denom. The denom will be like, it'll be like the delegation owner name concatenated with the validator name and so these are the capabilities you get when you own the delegation share. So once again, let's walk through it because that will probably be much simpler. So let's say Alice, she goes ahead and delegates to Sikka here, right? So she'll go ahead and delegate 100 atoms. And what she'll get is, can everyone see the thing at the bottom? Or is it blocking it? Okay.
100 Alice Sikka shares.
Yeah, okay, cool. Yeah. So yeah, so Alice gets yeah, sorry, my Zoom thing was blocking the bottom of the screen. Okay, so Alice gets so when she delegates 100 atoms, she'll get 100 Alice Sikka shares, and in state there'll be a state object that says, okay, there's this delegation object, the owner is Alice, it's 2 validators Sikka, the shares are 100, and the last withdrawal time is 50. What she could do is she could sell 50 of those Alice Sikka shares to Bob. And she can go, and if she tries to, now she'll say, okay, I'm going to unbond 100 atoms. The system will be like, no, you can't do that. You only have 50 Alice Sikka shares. So when you unbond, you have to actually, burn your atoms, your shares along with it. So now she'll say, sorry, the text here is wrong. It should say unbond 25 Alice Sikka shares. And then it will, decrease the number of shares by 25. Now Bob can, once ahead, similar to the change withdrawal address, now we just call it change owner. He'll say change owner and pass in 50 Alice Sikka shares. And he'll, burn those tokens. And what that will do is it will create a new delegation struct in state with 50 shares. So it decreases 50 shares from Alice's. So now she's back down to 25. And it creates a new one for Bob. And now Bob gets 50 Bob Sikka shares. And so these represent, claims on that delegation. And, the rest of it still works sort of exactly the same. The rewards now are kind of just done, based off of your own last withdrawal time and whatnot. So 2 pesky problems in this. One, it's that tokens that are in an active, wait, sorry, really quick before we go into that. So you'll see that, these Alice Sikka shares and Bob Sikka shares, while they are separate assets, right? They are separate denoms. They are still like truly fungible with each other. They both, because let's say I'm Charlie, I can buy 25 Alice Sikka shares or I can buy 25 Bob Sikka shares. It doesn't matter to me. I'll buy either one because as soon as I get them, my intent is just to go and change the owner of them and create a new delegation and to go create 25 Charlie Sikka shares. And so one thing we'll have to do in the Cosmos SDK is provide abstractions around denoms such that you can. I have an issue open for this in the Cosmos SDK where you can basically say that okay, both these 2 different denoms both share the same property, and so let's treat them the same for this purpose. So for example, let's say you have a Uniswap market, right? You want it to be, I don't know, DAI to Sikka shares. You want it, so you'd make it in that Uniswap market so it doesn't care whether it's getting Alice Sikka shares or Bob Sikka shares or Charlie Sikka shares. It will just care that it's getting blank Sikka shares. And so that does require some modification, like some updating to how assets work on the SDK. So yeah, 2 pesky problems. One is if a token is currently in an active redelegation from another validator, let's say, when I do these tokens, not only can I unbond, I can also redelegate, right? So I can turn Bob Sikka shares into, so Bob can turn Bob Sikka shares into Bob Chorus shares. He just has to call a instant redelegate and pass in his 50 Bob Sikka shares, and we'll mint him a new delegation struct where the owner is still Bob, but then the 2 validator is Chorus. The problem is when you're in this active redelegation for the period of 1 unbonding period, you are slashable for both the validator's faults. So if Sikka faults, you're slashable for them, and if Chorus faults, you're slashable for them. And thus for that short period of time, for that first unbonding period, the Bob Chorus shares are not fungible with other, Charlie Chorus shares because Charlie may have been delegated to Chorus for, ages, right? That's one. And number 2 is that newly bonded tokens are not subject to slashes that happen before they start bonding. So, Bob changes to Chorus, and Chorus had slash at block 10, but he changed at block 15. And so, there's some weirdness around that. So the simple solution to both of these problems at once is just say a delegation cannot issue derivatives until it has been bonded for at least one unbonding period. So let's say I bond tokens to Chorus. I have to wait 3 weeks before getting the derivative, the shares of them. And same with an instant redelegation. If I rebond from, Chorus to Stake Capital, I have to wait 3 weeks before I get the Stake Capital shares. Yeah, that's about it. Thanks.
That was great, Sunny. Thanks, really clear. Can you just go back to that last data structure there of the very last solution?
Yes.
So this owner is down as a constant there for the delegation share.
Right.
But it's not constant, is it?
We're no longer changing the owner of a delegation struct when you change owner, but we're rather just creating a new delegation struct.
Okay.
And
sure,
so that way,
yeah.
let's say Bob had bought all of Alice's tokens and decided to change the owner of them. It will just, once Alice's struct hits 0 shares, it will just be like pruned from state. So it'll just disappear.
Okay.
Hey, I have one question, which is like, why do you need the last withdrawal time? And whenever someone is transferring their delegation shares, why do they need to like change the last withdrawal, the withdraw address basically? Because you can keep the withdrawable tokens in a separate pool, so that the validator pool tokens can be fungible and easily transferable.
Sorry, can you repeat that? I didn't quite understand the question.
So instead of having the withdrawal address, you can keep those like withdrawn token into a separate pool.
Mm-hmm.
So then, like, let's say if Bob is transferring 50 tokens and he has withdrawn like, let's say 50 tokens already, then you don't need to have the last withdrawal time or withdraw address, basically, because these both are separate pool, and he can just transfer the 50 tokens which are already bonded.
One of the key designs of the fee distribution in the Cosmos SDK is that when the rewards for to Alice, so the rewards of the Sikka pool, right, are actually all in one pool together. The Alice rewards are not kept separately from the Bob rewards, and
I understand that part.
Right, and so that's why you need the last withdrawal time to do the account, because we do lazy accounting. We don't separate them. We use the last withdrawal time to calculate how many rewards from the overall pool should go to Alice, and that's why we need to keep track of that last withdrawal time. We don't want to when on a blockly basis, we do never want to be iterating over all delegators to distribute rewards to them.
I think not really, because if I understand the conversion rate, it should handle the part where you don't need to have the last withdrawal time.
Where there's no more conversion rate happening, right? So for now, we're assuming that all rewards are going in. So there's a separate delegation pool versus the reward pool, right? So because we're not auto rebonding atoms now in this version here, then the one-to-one between shares and atoms is always one-to-one.
I might be misunderstanding something. So let's say we have 2 variables for one validator delegations, right? So which is the one is active stake, which is bonded atoms, and another one is reward. So whenever there is so let's say for whatever reasons the rewards come, you just keep adding into the rewards. So now you have active stake plus rewards divided by whatever shares you have minted.
Yeah.
So in that case, you don't need to keep track of last withdrawal time.
No, because let's say there's 100 tokens in the pool, right? Alice decides to withdraw her rewards right now, right? So she gets 50 of them, right? And so now but she still has 50 shares, right?
Oh, I see.
And so now let's say later on, there's another 50 atoms re-added to the reward pool. She can't go ahead and say, oh, I have 50% of the shares, let me withdraw another 50, because no, she only is deserving of 25 of them right now, because a previous 50 are owed to Bob, and then half of the new atoms, 25. So Bob is actually entitled to 75 of them. Does that make sense?
Yeah, now I get it. So in that case, like, why don't you just burn the shares actually?
Because
so let's say
the shares are shares of the bonded pool, not of the reward pool. So when you withdraw rewards, you don't burn shares.
I understand it. So in my design, what I did was basically, so let's say initially you bought 100 shares. So let's say whenever you are withdrawing something, so right now let's say the exchange rate is 2. So for one shares it's 2. So let's say you are withdrawing 100 tokens, then I'll burn 50 tokens actually. So in that case, we don't need to manage the last withdrawal time.
So the design that you seem to be describing is the original like delegation vouchers from last summer.
Yeah.
But the problem here, like I mentioned, is it only works if all rewards are in the staking token, which might be the design of the. But for the Cosmos Hub, it was very much a design decision. Like, as far as I understand, it's still probably a design decision that we want rewards to be able to be paid in other tokens other than atoms.
So if I also just wanted to talk a little bit about, because after we worked with Sikka together in last June, we talked about this issue, and there was another hackathon in July, and we kind of took a different approach to solving sort of the same problem. So I also just wanted to explain a little bit what we did back then. So, as Sunny pointed out, right, the original design works kind of very nicely, where you have to share, and then you have this atom pool that gets filled up, and anyone can take any of these shares, they're perfectly fungible, and just redeem it for the accumulating atoms. And you can take it to other chains. You can use it there. There's no need to bring it back. There's no need for withdrawal address and those kind of things. And as Sunny pointed out, this kind of starts falling apart when you have basically the income starts to be in various different tokens. And I guess this will depend a lot on what's the network, what's their goal, and if they do want to have fees in various different tokens, but presumably some will. And for Cosmos, there's very much the idea, right, that if you're routing basically packets of tokens across many networks, that you can pay in this native token of whatever you're routing through. So then, totally is the case, right, that in Cosmos, it will make sense to accept fees to be paid in various different tokens, right? And so then you have this challenge here. So we thought there was a sort of a very elegant way of solving this problem, as well as another problem that I'll get to in a second. And that way is basically to say all of those non-atom rewards, they go into kind of a separate pool, and they're auctioned off on chain for atoms. And that sort of happens, continuously and automatically. And the frequency that this happens would depend on kind of how much those fee revenues would be. So let's say it's 0.1% of the rewards that atoms represent, block rewards, right? Then probably doing it once a day would be fine. So what would happen then is that when this auction happens, you just have some additional atoms that get paid into this reward pool, and it basically makes kind of no difference for these shares. It's not noticeable. Of course, there is a little bit that effect if you have this kind of mechanism,
that you have with shares of companies as well, where, you know, if you own a share, like right before dividend gets paid, it's worth a little bit more than afterwards. But here, you know, you would essentially have sort of dividends from like non-atom income, but you could pay these dividends, you know, on a daily or maybe every few hours or something basis. So this effect is going to be so tiny, it will be, you know, it could be ignored. And so then you just have these extra rewards, right? And then basically the old design works, and, you know, there's much more simplicity with the design. You know, you have perfectly fungible tokens. There are no NFTs. There's no withdrawal ladders. And so I think there's a great benefit from that side, just in terms of keeping it very, very simple. But there's also a great benefit if you look at it from another perspective, which, let's say you are now staking atoms on the Cosmos Hub, and you're earning atom rewards, and, you know, that's nice, right? Because like that's what you bought in the first place, so getting more of them makes a lot of sense. But now let's say you're also earning like some other tokens, and maybe down the line you're gonna have like 5, 10, 50, 100 different tokens that people can pay fees in. So what you essentially start to have is that all of these delegators are gonna get like minuscule amounts, basically dust, in like lots of different tokens. Of course, that's like a nightmare, right? Like you don't want to have like atom rewards as well as 100 different tokens in these tiny amounts that then, you know, you have to go and try to convert it to some token that you actually want. So I think from also a user experience perspective, you don't actually want to get rewards in like lots and lots of different tokens. It's much nicer if you just get more atoms. Of course, this is all a little bit specific to the Cosmos Hub and sort of to the specific use case that the Cosmos Hub is trying to fill. But that's kind of the, you know, the alternative approach that one could take. And, you know, for these on-chain auctions, you could use something like Uniswap, so it would be very, very simple to do that. And yeah, so that's also something we built in a hackathon in Seoul last year. So yeah, I just wanted to share that kind of as a sort of another version, another alternative design for delegation vouchers that, you know, we did some work on.
Right.
I have. Sorry, go ahead.
Oh no, yeah.
I have some questions in regards to fungibility across validators. So like the basis of validator fungibility. So like the value is equal because you basically can switch validators for these delegation vouchers, right? But I was just kind of wondering. Sorry, go ahead.
Well, it's not. The goal here was fungibility between Alice shares and Bob shares. It was not about fungibility between validators, and it's not really intended to be fungible between validators. I mean, it will be a little bit because of that instant redelegation, because you can buy Alice Sikka shares and change them to Alice Chorus shares. They're close to fungible, but they might be slightly different because of slashing risks, which is what you want. Yeah. You want these to not be fungible because you want the shares to be somewhat reflective of the slashing risk of each validator.
Yeah, and just kind of as a follow-up question to that, like, do you think these shares, because we have, specific to the Cosmos Hub, there's a limit of like 7 redelegations, as far as I understand. So, you know, obviously, a specific validator share would be, could be less in value if it's in that part of that 6 redelegation period, like, so that would have to account for that as well.
Well, this is why this kind of goes back to this piece of, you know, let's just make it so if you've been bonded to a validator for less than an unbonding period, just no shares at all. That way we get rid of all edge cases.
Okay, cool. Thank you.
I realized I actually forgot this one slide. Basically, a couple of things is one, we can still, here I actually I made it so that, okay, you know, new rewards are going directly into the reward pool, but there's no reason actually in this design why you can't still auto rebond all atom rewards and allow other token rewards to use the F1 fee distribution. So that's completely okay still. We would need to decide whether peripheral capabilities like voting, right? Like your voting rights, is that, so let's say you're in this case, right, where Alice has already sold some 50 of her Alice Sikka shares to Bob, but Bob hasn't called change owner yet. Does Alice only have the voting rights of 50 atoms, or does she have the voting rights of 100 atoms? That's a decision that has to be made. I mean, it can go either way. I personally think that she should get all of the voting rights until Bob changes owner, but no, that's my opinion. 2, we can probably make it so the transfers that happen on the hub itself automatically cause change owner. So when Alice sends to Bob, it could just trigger a hook that automatically changes the owner to Bob. So that way you only have to manually call change owner if you're doing the transfer on a different chain other than the hub. And then finally, we should add a time lock module. So if this is kind of like not specific to this design, but this is just equipped for something for like all staking derivative stuff, where if we're having staking derivatives, we should have a system where, let's say as a validator operator, I want to show that I'm long-term bonded. I can take my derivatives and put them in a token lock module, which basically prevents me from moving them for like, it basically reinserts me into a forced unbonding period, or like, so I can't move them for at least like 3 weeks notice or something like that. So that's a separate point. But yeah. So I agree that, so I think that, either this model or the auction model, to me seems like the right way to go. I do see the benefits of, not having so much dust and stuff and all these different tokens, but at the same time, then in that case, we do have to guarantee that there is a market for people who are, buying from the auction. So you need a setup, a participant set who's willing to play those auctions.
Oh, if there's value, then
yeah, totally.
Will, right?
Yeah. But it comes to how liquid it is, right? Because if there's less people playing that market, then and not actually buying they might be buying from the auction at a discounted price, which means the validators are getting less atoms than the fee tokens that they sold off for.
Yeah, sure. I mean, maybe if it's very liquid, it's like, let's say it's a discount of 10% or something like that. I mean, as soon as it gets a substantial amount, I'm sure that there would be a discount that's much less. But even if it's a discount of 10%, that's probably still economically better for me as like a delegator than if I get like lots of little coins and then I have to go and like transfer them somewhere, liquidate them. I'm probably going to pay more in fees and certainly in hassle to do that.
Mm-hmm. Yeah. You also need a fairly liquid amount of atoms. That's the other thing, which, maybe not a big issue, but you will need liquid atoms. My issue is less with the fees on the hub. My issue is more when we get to shared security. I imagine that like a chain that's being shared security might want to give some of its rewards in its native token. And so that's where I think that the issue becomes a bit greater than in the fees.
Sunny, there's a few questions about subkeys there in the channel. Do you want to just introduce the idea of subkeys and maybe talk a bit about how subkey functionality could help this design, make it more flexible?
So as far, so the whole subkey stuff has gone quite a bit, like progressed quite a bit since I worked on it, but subkeys are a pretty independent design thing in my opinion. But essentially the idea of subkeys was just that an account can provision additional keys other than its master key to do different functionality. So I can basically, if I want to provision a new key for, I don't want, one of the annoying things about participating in Cosmos governance is I have to Dave and I have this complex multi-sig procedure to sign all transactions for security reasons, but it's really annoying for governance voting. It'll be nice if I can provision a specific key that all it's able to do is vote in governance and nothing else. And that one I can keep a little bit more hot. And so that's what the subkey system is designed to do, where like our validator account, it could say, okay, this key is allowed to do voting only transactions. There might be ways where it relates to this, where maybe, one of the ways that, one of the things that you might really want is a provision, a new key that all it's allowed to do is call withdraw rewards, because that way you could just constantly, maybe you can only call withdraw rewards and rebond. So that way you can just have that as a hotkey, and you can keep that on your phone if you want to, and you can just like regularly just withdraw rewards and then rebond the rewards as a stake. So that's something that kind of helps with the subkeys, but for the most part, it's a pretty independent thing to this.
Okay. Hyung, do you want to jump in there? I see a few comments just related to the subkey functionality. Do you see this working in a different way?
Okay, so one of the expansion of subkey from our team is to build a subkey which does not have a private original private key, but only having a member key. So it's a subkey, only subkey, but does not have a main private key. So if you have only one member key, then a transaction to change this member key can be seen as a transfer of ownership from myself to another one. So that is our analysis of applying this subkey thing to transfer locked assets. So if you can send the ownership of an account to another person, then you can trade these assets. So you can just trade this account against some liquid assets. So that is our approach to make locked asset, which is one of the locked asset is delegation. So that is how we approach to liquidate this locked asset.
How would you like use this in a DeFi sense though, right? Like how do I assetize the ability to change the subkey ownership, right? Like one of the goals of the staking derivatives is you want to make it easy to use in DeFi purposes, right?
Yeah. So we already built a POC of OTC market to trade staked atom against liquid atom. So the trade will be done via atomic swap. One side of atomic swap will be a transfer of ownership. The other side will be a transfer of liquid atom. So if both sides agree about the contents of the agreement, then they can build an atomic transaction so that this transaction will execute these two directional transaction at the same time.
Right. So like I said, I can see how this works in an OTC style system, right? And so this is kind of what this is essentially it's an NFT model of doing this. But the problem with the NFT, how would I put this into a Uniswap contract, for example, right? Or how would I put this into an order book? Or how do I get Kava CDPs? Like how do I get the price oracle data of each of these NFTs independently?
Yeah, so this solution does not solve a fungibility issue. So each of the account is like an NFT, it's non-fungible. So we cannot solve any fungibility issue for this.
Right. And yeah, so if we don't want fungibility, there are like easier ways we can actually do something much simpler like one of these earlier models. But where we just, this would actually be a very simple change where we already have this struct in state. We just have to turn it into an asset where instead get rid of the from delegator as in state and just say, okay, it's whoever holds the asset is the delegator. That's pretty simple to do and probably safer than transferring ownership of an entire account, because there might be other things that in that account you don't want to transfer ownership of. But it's for me, the fungibility is a key design goal. If because I really want these things to be usable in different DeFi applications.
Yeah, I agree.
Okay, I'll try and get a couple more questions, as I know we're getting short on time here. So Colin's asking about, can we separate out the rewards? So I would keep my stake tokens, but I'd be able to sell on the rewards to somebody else. I think this kind of goes back to what Felix was talking about earlier of an interest rate swap. So I'm basically selling the rewards onto somebody else, but keeping the actual asset. Sunny, how do you see that fitting into this model, or you think that's a completely different design?
Yeah, sure. So this is actually one of the things we were thinking about back in Berlin, but the problem is then the reward vouchers would still have to be NFTs, because it still falls into the same problem. It has to keep track of last withdrawal time, and so you'd have this weird situation where the staked vouchers are fungible tokens, but the rewards are NFTs. But it's like, what's the point of the staked derivatives if they don't entitle? So let's say I delegated to Chorus, and I have 50 stake fungible token like vouchers, and then I have an NFT that represents my delegation to Chorus, and I send my 50 tokens to Brendan. But if the NFT is still in my name, the reward voucher is still in my name, what are those 50 tokens like even representing anymore at this point? Like, I guess all you could do with them is unbond them, but that's kind of like, I feel like the goal is you want the reward and the staking amount to be linked, because otherwise why would someone buy them? All they're buying is then they're just buying atoms with no upside, because they can't earn rewards, but they only have slashing risk.
Yeah, I mean, so the way I look at it is this. If I need liquidity, but I want to keep the underlying, I do believe that there will be people that will basically create discounted cash flow valuations for the future value of what those returns could be, similar to like an annuity stream or a fixed income security. And for the first time ever, you can actually separate the two, whereas today in the financial world, you can't separate the two. They're inherently linked. So I think it's important that there will be people in these new business models that we're going to create that will be looking for programmatic cash flow. And then there will be methodologies put in place to evaluate programmatic cash flow. And as someone who owns the underlying, who's long it, if there is anticipation from people of increased staking rewards, if staking rates become a new risk-free rate of a new global financial system that things are built on top of, there will be people who just want like fixed income purchasing. They may not want the underlying, they just want to be entitled to that revenue stream.
So what I would say is I agree with that. So what you could actually do is, once you have this delegation share token as a primitive, then you can actually put these into, you can actually split these assets if you want to, and like separate out the unbond and redelegate capability from the change owner capability. So you can imagine, let's say I put, I created a smart contract, I put delegation share tokens into that smart contract, and that issues so I'm still the owner of the delegation share, but it issues a new token which only allows someone to change the owner. And so that way you could go ahead and buy that change owner token, and using my shares out of there, you could go ahead and change the owner to yourself, and you'd start earning those rewards and then you could sell that change owner token to someone else. They can start earning those, and they can change the owner, so they start earning the rewards, but they never have the ability to unbond the underlying. And that's one way you could do it.
Cool.
Interesting.
I think we're just starting to get into some interesting discussions. Unfortunately, we're running out of time. So let's come back to that, because I think that's interesting. I know Hyung had a design for delegation tranches that was about how you kind of split up the constituent parts of this. So I think we should definitely follow on with that. The other thing that I think is really interesting is this trifecta that Dojimos is talking about. So a trifecta of value fungibility, validator fungibility, and collateralization. I'm really interested to hear more about that. So maybe in the next session, we can get Dojimos to present that idea and maybe have a discussion about that. See, like, is it really a trifecta, or is there solutions that would solve for each of those? So 3 minutes left. Yeah, briefly, we wanted to just kind of get some ideas of what we should talk about next week. So maybe, like I said, we can talk about the Dojima solution. We're looking to start going through some of the projects on the next call. So obviously we did delegation vouchers today and Sunny's variation on that. So I think on the next call, we will plan to do one or maybe two of the other projects. Does that sound interesting to everybody, or is there other topics people would like to discuss? Okay, I see some comment there about maybe covering attack vectors. We can certainly get to that. Sorry, Marwan, you're going to say?
I was just saying that it was good. I mean, it sounds like a good plan.
Yeah, probably while discussing the design, we can also discuss the attack vectors and all the things.
Sorry, say that again. We could also discuss.
So, like, while discussing the designs, we can also cover the attack vectors part as well.
Yeah.
Because someone has question on like attack vectors and.
Yeah, certainly we can cover that. And there's talk of dark DAO there. Okay, so yeah, look, 1 more minute if anyone wants to just suggest something else. Otherwise, what we're planning on doing is covering a couple of projects. I'll talk to Brian and Felix, and then we'll reach out like we did with Sunny. We'll reach out to 1 or 2 of the projects and give people some time to prep. Everybody okay with the format there in terms of having somebody pitch a proposal and then having an open discussion about it? Does that work for everybody?
Yep, I thought that worked really well.
Yep.
Okay, cool. So yeah, just to say, like I said, stick stuff on GitHub if you want to get a discussion going. And thanks a million to Sunny. Sunny, that was an amazing presentation, really good, really interesting, and a great discussion. So yeah, thank you everybody, and we'll talk to you all again in 2 weeks. Thanks very much.
Thank you.
Thank you, everybody.
Bye, everyone.
Cheers.
Bye, guys.